Morning students. Today we will discuss about the modern periodic table and trends in properties in it. In the chapter Periodic Classification of Elements. Henry Moseley proposed the modern periodic table and stated the modern periodic law as the properties of elements are a periodic function of their atomic number. It means that he considered the atomic number as the basis for modern periodic table instead of the atomic mass. And this will also overcome the limitations of Manley periodic table. In the modern periodic table, there are 18 vertical columns known as the group and 7 horizontal rows known as the periods. And this whole arrangement of elements is based on the electronic configuration. That's why the hydrogen is light at the top of the alkali metal in the modern periodic table because only one electron is present in its valence shell. And the position of an element tells about the chemical reactivity. Also, the valence electron determines the number of bonds formed by an element. So, it's the position of elements in the modern periodic table. Now, we will discuss about the different periods and groups in the modern periodic table. There are 18 groups and 7 periods. So these are the 7 periods, and the first group is known as the alkali metals. This is the second group known as the alkali earth metals, and from scandium to zinc, these are the transition metals or D block elements. Now, last group is known as the noble gases, and this is the group number from 13 to 17, and group number 17 is known as the halogens. These are the F block elements, and this series is known as the lanthanoids, and this series is known as the actinoids. So basically it is the classification of different groups and periods in the modern periodic table. And here group number 13 to group number 17, some important names are given to these groups, like group number 15 is known as the nitrogens, group number 16 is known as the chalcones, and group number 17 is known as the halogens. So basically we will study about the trends in the modern periodic table. Like first one is the valency. It is determined by the number of valence electrons present in the outermost shell. For example, what is the trend along the period? Let us take an example of the third period, that is the sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and the argon. It is the third period, and there are from valence electron varies from 1 to 4 and 5 to 8. It means that the valency will increases from 1 to 4 and decreases from 5 to 8, because we calculate the valency from as the H minus number of valence electron if the valence electrons are greater than the 4. Now, what is the trend down the group? On moving from up to down, the valency will be same. Let us take an example of the first group: hydrogen, lithium, sodium, potassium, and it having the atomic number 1, 3, 11 and 19 respectively. So what is the electronic configuration? It is 1, 2, 1 and 2, 8, 1 and 2, 8, 8, 1. It means that there are one valence electron present in the outermost shell. It means valency will be same. Now the second property is the atomic size. Basically atomic size is the distance between the nucleus and the last electron. it means that it is the radius of an atom, like it is the nucleus and this is the K shell, L shell, and electron is lie in the L shell. It means it is the distance from the nucleus and the electron. So basically referred as the radius. And what will be the trend along the period? It means on moving from left to right, size of the atom decreases because electron is added in the same shell. Because one electron is increased and added in the same shell. That's why atomic size decreases, because protons are all also increases. Now trend along the down the group. On moving from up to down, the size will increases because number of shells will increases. For example, in case of hydrogen, there is only one shell, that is the K, and in case of lithium there is two shells, K, L, and in case of sodium there are three shells, Kl, M, and similarly in potassium there are four shells, Kl, Mn. It means number of shells are increasing and the size of the atom means the distance between the nucleus and the electron are also increases, hence atomic size increases down the group. Now next property is the metallic character. Basically metals are found on the left hand side of the periodic table and the metallic character is increases from on moving from down the group, because metal is basically the loss of an electron and it is easy to lose an electron from down the group, and it is quite difficult to lose an electron on moving from left to right because proton increases and electron loss will be quite difficult. That's why metallic character decreases along the period. And this metallic character is also proportional to the basic oxides. If metallic character increases, then basic oxides are also increases. We will discuss further. Now the next one is the non-metallic character. Basically non-metallic character depends upon the gain of an electron, and along the period means moving from left to right, the non-metallic character increases because it's an easy to gain an electron. But from moving down the group, the non-metallic character decreases because it is not easy to gain an electron and only metallic character increases down the group. And what about the oxides? Oxides are basically depends upon the metallic and the non-metallic character. Metallic character forms the basic oxides. If it increases, it means basic oxides increases. But on moving from left to right, metallic character decreases. That's why basic character decreases and acidic character increases. And on moving down the group, the metallic character increases. That's why basic oxides are also increases, but the acidic character decreases. So it's all about the trends in the properties in the modern periodic table. Now let's try two questions. First one is the how many groups are present in the modern periodic table, and the second one is the group 16 means oxygen family is known as from which name. So you will write your answers in the chat box. I will check personally. Now it's all about the modern periodic table and its properties. Thank you.